Our goal here is to demonstrate some basic principles, techniques, tools, components used in the wiring of an electrical system for a home-built aircraft. You can then decide whether you are able or willing to tackle this job yourself.
A great place to start our discussion is to think about the wire you will be using in your home build. There are two aspects to choosing the proper wire product for your plane. It must be the correct type and it must be the correct size.
Look here, these two wires, how are they different? Well, certainly one's a lot larger than the other. Certainly one costs a lot more to purchase than the other. And one can carry a lot more current through it. And that's the whole point of our wire gauge chart. Any wire you purchase or use in your aircraft will be sized by this wire gauge chart. Now here's a brief introduction to our crimp-on wire connectors or wire termination devices. Now this is our crimp-on connector from the aviation supply house. I want you to compare that with one I picked up from the auto parts store. Let's look inside the barrel. You can see the difference. Since every one of your circuits must terminate to a ground, wouldn't it be great to have a common, convenient place to attach all of your grounds at the very same point? And that's what this component is all about. Here's an example of a starter solenoid or battery contactor, as they may be called or used. And this is nothing more than a big switch. When it comes to stripping wires, everybody seems to have their favorite tool to do that. Well, I'm going to show you what I think is a better way. When you strip a wire, it's very important not to nick the conductor inside. You want to remove the insulation, but you don't want to go too deep. Number of the wire gauge. Notice that tiny hole at the bottom there, that's for number size 18 through 20. Next hole up is 16 and 14. Next one up is number 12, etc. This is the one you shouldn't use. This is from your auto parts store. And we'll talk a moment why this is less than desirable. This is the one you want to use. Necessary for a proper crimp is critical, and you don't want to crimp something just halfway, so the ratcheting feature makes darn sure that it is squeezed all the way before letting you off the hook. And then I can go ahead and squeeze. And I use my second hand down here because I'm not strong enough for one hand. And because it's ratcheting, it will only release after I get it all the way. It will fall out, and let's take an examination of that crimp. It does a beautiful job, you might say perfect, every time.
This technique of soldering is used in lieu of having a crimper large enough to handle this connector. Because we don't have a soldering iron large enough to heat this size of connector, a careful application of a propane torch will work just fine. In the world of experimental aviation, where every installation is unique, it is up to you to come up with creative ways to support and route your wiring in such a way that it will not be subject to sharp edges.
Have you ever wondered how they make the nice round cutouts for your avionics panel? There's the small size as opposed to the large. Place the bolt.
How do we begin the process of designing the electrical circuits for our plane? There are as many panel designs as there are pilots, with many decisions being molded by economic factors, degrees of complexity, and types of flying, VFR versus IFR.
Let's talk about possibly the simplest circuit you could have within your aircraft. Our story is going to begin with the battery. One circuit wired up with a 15 amp fuse. Let's trace this red wire and notice that our one circuit goes into a simple toggle switch which turns the flow on and off. On and off to what? Well, in this example, this would be one of our landing lights. Now, I know that's not a landing light, but here is our schematic diagram.
Should I use fuses or circuit breakers? Does it matter?
Well, that's a super question. Let's address this question by contrasting cost, safety, and convenience as the competing issues.
Shouldn't you solder those wire terminals after you crimp them for a better connection?
Refuse the urge to solder those crimp-on connectors.
Oh, really?
They're designed to not use any solder at all. If properly crimped with the correct tool, they will not fail you. The reason soldering could hurt the connection is that as solder fills the strands of the copper wire inside the insulation, the wire now takes on the characteristics of a solid wire. We know, don't we, that the reason we do not use solid wires is that it loses the ability to flex and will fatigue from all of those aircraft vibrations and may one day break. Sometimes we have to solder connections where necessary, but usually not where crimping was intended.
Is there a limit to how much electrical stuff I can have in my plane? How many circuits should I have in my plane? Is it important to ground the engine block? Why do they call it a main bus or a ground bus?
If you have any more questions, don't hesitate to come back and ask.
I'll be back.